So Bruce Basil Matthews is the senior solutions architect at Mirantis, and as I already mentioned, he is very passionately involved in this service mesh, and he's probably the best person to talk about service mesh comparisons. But on a broader side of his skill set, he also comes from theater background, and it's a coincidence that we have him today on Shakespeare's birthday. So we are lucky to have this presentation. It's a coincidence, so it's going to be very interesting. And I've heard him before in front of live audience. He really keeps the audience engaged, and you can see that he has that knack which comes from his background in acting. So welcome, Bruce, and I'll talk a little bit advancing to the next slide about the topic. So Bruce, we and many of us in the audience, we are new to this concept of service mesh. So we'd like to know a little bit from you on the introductory side, and then we're also, kind of curious what's happening in the service mesh wars, so to say. So you have biggies like Istio and Envoy, and on the other side you have Linkerd and so many of them. And right now we are spoiled for choice, if you ask me. And I have tried my own hand at 1.0 of Istio, and it's still not very clear to me which way the things are going to go. So it will be very interesting for us to get in at this point of time to get your expert view of this. So over to you, Bruce.
Oh, Vinayak, thank you so very much for your kind words. And yes, having come from an acting background, it helps me to do these presentations, hopefully. As Vinayak said, today is officially Shakespeare's birthday, the 23rd of April. That makes him 456 years old today. But having run around with him as a kid when we were growing up, I can tell you he doesn't look a day over 300. In any case, today's topic is really one that's near and dear to my heart. It's about service meshing. And there are many different aspects of containerized computing and microservices that are in the phase of development in our country. And some of those technologies involve sort of microservice application layer experimentation. What service meshes bring to the table is the ability to communicate between those services in a hopefully secured, safe, reliable way that helps to standardize how things are going from one aspect of your application service to the next within this microservice architecture. When we talk about a service mesh itself, it has some key capabilities built in. This is what establishes the category, I guess, of service meshing sitting on top of clusters such as Kubernetes or even Mesos. One is service discovery, and that lets you to figure out things like your DNS capabilities, which load balancers you have access to, all of the things within the Kubernetes framework that assist the application developer without the application having to be hard-coded to take advantage of them. As I indicated, load balancing is a big part of that. It means that your application services can scale as on demand. So as a new instance of a particular service comes into play, it immediately discovers where in the load balancing schema it's supposed to be, and the traffic gets balanced automatically, all of those kinds of things through a service mesh. And of course, it wouldn't be complete without having end-to-end encryption, meaning to say that from the moment it enters the cluster, you have a secured way of communication from microservice to microservice as it passes through the application. And you have to be authorized to be able to do that. So there's an entire built-in certificate capability that keeps everything according to Hoyle. And finally, and this is more the application developer's realm than anything else, support for circuit breaker patterning, which allows the application developer to control what happens when something goes wrong. If this service breaks, separate the code out into these two services and balance them 80% to 40% or 20%, those kinds of things. We call this traffic shaping, the ability to provide a specific level of service to a particular component of the microservices within your application, and to control the quality of that service to ensure that no one is getting starved and everyone is able to eat, which is, I hope, something we can continue to do in today's world. So the circuit breaker patterning itself allows you to determine whether traffic should be continued if a routed portion is not operating properly or not. And it's at the application developer's discretion. That also puts a great amount of required thought on how the flow should go in the event of some change in the workflow between microservices. In this modular service development, you can actually integrate across disparate teams, and as a result, everyone will be taking advantage of the same catalog of services through the discovery mechanism. This really helps to ensure that nobody goes far afield and put things into your application that are unique and that can only be accessed from where they are. But the service meshing capability really didn't develop all at once. It went through a series of different architectures as it was in development. The original one was called a library, and what it meant was that each one of the services were placed into a modular component of bits that was then injected directly into your container. Each container held onto an entire copy of all of the services that were able to be provided in the mesh. This made sure that each one of the containers had everything that it needed and was self-contained. But there are some downs to that, and I'll get into more of them as we go. But the primary one was that you had to change them out when you added a new feature or capability, and then you had to recompile your containers, which was a cumbersome chore. The next iteration of architecture for the service mesh became known as the node agent. This was kind of an advancement because the entire cluster that consisted of multiple nodes, each node would have its own agent, and each container or pod hosted on that node would take advantage of that agent as the proxy to redirect all of the traffic. This was an advancement because not every container needed to know everything about all the services available. However, if that node itself, the agent, went down, it meant you lost connection with all of the pods or containers sitting on that node. So we had a bit more work to do. The current iteration, and the one that's most prevalent in the market today, is called Sidecar. Sidecar is actually a separate container that mirrors the original container. So every container on a particular pod or in a particular node has its own sidecar container that acts as a proxy service, and all of the network traffic that's going to go into or out of that microservice container is going to go through that proxy to get there. This has multiple advantages, and I'll be going into a lot more of them as we go. But the primary one is that if it fails, it only affects that container, and you can spin up a new one. It spins up its own sidecar, and so on.